Hello everyone, welcome back to our channel. In the last tutorial we talked about the glTF format, about what it is, why it is important, and how to create glTFs via Grasshopper. In this video tutorial, in the second part, we will explain how to add metadata in these glTF files. Metadata such as multiple materials, material names, object names, and transformations. But before we get started, don't forget to like this video and to subscribe if you haven't done so. So let's get started. In today's example, we have this Lamborghini, which was created by my colleague Michele Farina. The main parameters of this model are the plate. So in the back we have this plate, and we can change the name of this plate. For example, ShapeDiver. Then we have the grill, so we can change different styles of grills. So for example, we have the default one. You can see here the grill in this part, and we can see it here in the front. We have default, we have hexagonal, staggered, and triangle. So that's the grill. Then we have also the wheels. The wheels are even using kangaroo to be able to create this effect. And then here we have, for example, the number of spokes. So I can increase the number of spokes. We have also here, for example, ingoing force and rotational force near center and also far from center. Then of course we have simple basic parameters such as the body color. So we can also change the body color, for example, or we can also change trim color, and so on. So there are plenty of options in this model. And at the end of this model, we are packing all of these parametric parts and the static part of the model into a glTF. This is what we reviewed in the last video. So we can right-click in this right-click in this glTF component, glTF display component, which you can find here in the ShapeDiver tab, glTF 2.0 display component. I just need to right-click on it, save glTF, and let's save it again. Here I had it already, but we can save it again. And now let's have a look at this model in other platforms. So for example, here we have a Sketchfab, so we can just drag and drop in a Sketchfab this Lambo model that we just created through Grasshopper. Now we will be able to upload it into other platforms like Sketchfab. So here Sketchfab is just processing our model, and we will be able to see the final result. So the model is ready. We can have a look at it in Edit 3D settings. And here we are. We just went from Grasshopper to a Sketchfab through our glTF. Now, as you can see, the glTF contains all the information. This single file contains all the information of all the materials that we are using here. If we go into materials, we can click on the different parts of the body, and we can see that here we have the material name. We have here all the materials that this model contains. If we, for example, click on the wheels, we can see that the wheels already contain a roughness map, already contained a normal map, and all of that was brought through Grasshopper, was brought into my glTF through Grasshopper. So let's have a look at this model in another platform. So in this case it's ThreeJS, which is the same framework that we use in ShapeDiver. So we can also just drag and drop the Lambo model. So here we have it. And if we check here the scene tree, so what we have in the scene, we can see that we have a GLB of the Lambo. And if I expand this, I can see that inside my main Lambo model, I have children, I have other sub-objects. So I continue expanding and I can see that I have exterior, interior, wheels. So here inside exterior, I have also more children of this model. So for example, here the body, the doors, the trimming, glass, lights, etc. All of that is inside the parent, which in this case is exterior. And I can also hide the parent. So that means everything else that is inside, all the children will be also hidden. So if I can click there, I can now just see the interior of my model, which contains, here we can also check the interior, contains other children, which are the seats, engine, armrest, etc. So all of this structure that we see here in this glTF was also created through Grasshopper. So how do you add all of this metadata? How do I add all of these materials, material names? All of these textures are already internalized in my glTF model. About the naming and how the objects are organized internally, all of that is done here in Grasshopper. So to begin with, we can have a look at this section where we have doors. So here we have the doors, just a single one without any metadata. So that means that, let me hide here this one. That means that if I come here to display glTF 2.0, and then I connect the doors here, then I can see that I don't have any materials, I don't have any other data, only the mesh. So I can, of course, right-click here, save glTF, here test door, I can save it, and then if we check this door in the Windows viewer, we can see that the model doesn't contain other thing, just the geometry. So how do we start adding then this extra data? So the first thing is just through this material input. So in one side we have the geometry input, which is the meshes, and in the other side we have the material input, which in this case I have them already prepared here. These materials are created through the glTF 2.0 material component, also available in the ShapeDiver plugin, display glTF 2.0 component. And with this one, you can specify everything that you need for your material. So in this case, I'm specifying the color, I'm specifying the base color texture, metalness factor, roughness factor, metallic roughness texture, normal texture, emissive factor, emissive texture, alpha mode, alpha cutoff, and double-sided. So all of this is specified already in this material. If you don't know how to create these materials, you can already go to some websites online, textures.com, for example, and there you can find all of these images that you need to be able to create a material. So in this case, we are using the import bitmap component, also from the ShapeDiver plugin, inputs, import bitmap component, so that our image is imported inside Grasshopper, and then in that way we can embed the entire bitmap, the entire pixel by pixel in our model, in our glTF. Additionally, of course, here we have also the name of the material, in this case body, which is exactly the same name that we get here, for example, in Sketchfab. So in Sketchfab, all of these names that we see here, all of them are coming from our glTF 2.0 material, from the name attribute, which is one of the inputs. Now, if we go back to our list of materials, then we can see that we have, for each mesh that we have here, we have different materials. So for example, we have here the exterior, so we have material body. Then let's check the next one, that's material black. The next one is the glass itself. And all of these materials were defined through the glTF 2.0 material component. If I want to add this material in the glTF, then I just have to include my list of materials here, and I need to graft. So right click, graft my my meshes. So in this case, I have 5 meshes. That means that when I graft, I have 5 branches in our tree, and that relates to these 5 materials that we have. Each material will be linked to each branch. So if you have 10 materials, you will need 10 branches. Now, each branch can contain as many meshes, as many geometry as you want, but it needs to be grouped into branches. Now, if we just do that, and we check our model here in Grasshopper, we can see that it already contains all of the materials assigned to the right geometry. If I right click here and I say save glTF 2.0 material, sorry, save glTF 2.0, and I can say test door. Yes, I want to save it again. And if we check it again, then we can see that our glTF already contains our materials. And as you can see, when the light hits our metallic part, it reflects. So all of these metalness factor, roughness factor that were defined in our glTF 2.0 material component are being now exported in our glTF. So if we go to the other side where it's rough, then we don't see any light reflecting, but in the outside where is everything metallic or glass, then we can see the light reflecting. Okay, so now we have geometry and we have materials, but we don't have just a single door, no? We have 2 doors. So what we can do, well, the normal thing to do would be to just mirror our geometry. So we can here connect the mirror. Then we can merge our 2 components. And that's it. However, when we do this, we are now increasing by twice the size of our glTF. So now if we see our GLB has a size of 289 kilobytes. So now if we say our glTF with double the geometry, of course, our size of our glTF would also go double. So now we have 576 kilobytes. But if we check the model, of course, now we have the 2 doors. So how can we export these 2 doors, which are exactly the same, it's just mirrored, but it's exactly the same geometry, without duplicating, without increasing the size of our model by twice the size? That's also through another component, which is here in the attributes section of the ShapeDiver plugin, which is called the attach transformations component. So what we will do is that instead of mirroring here in Grasshopper, we will mirror in the viewer where this model is created through transformations. So that means that when I connect this into the geometry input, then I need also a list of transformations. In this case, my list will be the mirror, but also I need a transformation for the door itself that is not being transformed. So my original door plus the mirror. So in this case, we can put a move component with 0 moving, because we are not gonna do anything to this door in general. So we can put a move component with 0 point, so with no moving at all, because the only thing that we want is to keep the geometry as it is, but we want to mirror the second one. So we can just internalize here our origin point. We can merge our transformations. So one transformation is not moving, the second one is mirroring my door. Then that's my list of transformations. Now, as you can see here, we have 5 branches, and here we also have 5 branches. We have increased absolutely nothing the amount of geometry we have. However, inside this geometry we have metadata, which is our transformations. So if I connect that into the glTF component, we get again the 2 doors, but when we save this in our glTF 2.0 file, which is now 576 kilobytes, our file size will decrease again to half the size, because we are just sending a single door. So we can see here, if we update 289 kilobytes. So we reduced our file size, but if we open the model, we still get the 2 doors. So we have half the size of our glTF file, but we have still 2 doors. Again, this is because we're sending these transformations as metadata, not as geometry itself. So now we have materials already, we have transformations already, but what if I also want to send the name? So we saw in the ThreeJS viewer that we had these names in the objects, and we want to also attach these names in our geometry. If that is the case, then we have to use the attribute system of the ShapeDiver plugin. Here in the attribute system, we have something called the construct attribute component, and this one allows us to create any custom attribute. In this case, we will create the name attribute. So in the key value, we will put name, and in the value, we will put, in this case, doors. Now, this just gives us an attribute which has just a single attribute, which will be the name. But we want multiple attributes. We want the material attribute and also the transformation attribute. So that means that here I need to have the list of all the attributes that I want. So I know that I want the name, I know that I want the material, and I know also that I want the transform. So we have 3 attributes, and now for these 3 attributes, we need also a list of the 3 values that we want. So in this case, because we have a single name and multiple materials, we will have to use the longest list component. This one will allow us to repeat our door's name. So now we have 5 doors for our 5 meshes, 5 materials, and now we just need 5 transformations as well. Now here the transformations are 2 per mesh. So we need to convert these 2 transformations into a single data type. For that, we have another component, which is the create transform list. So this component will take our 2 transformations. It can be 2 or it can be more. It depends on your use case. And we'll group it into a transform list. So in that case, we can have then 1 transformation list per mesh. So to recap, we have now here 5 names, 5 materials, and 5 transformation lists. Now we can merge that. And because we want 3 attributes per mesh, then we need to graph our materials in this case, so that in our output we get separated by a branch each of our attribute values, so that at the end we get 5 branches with 3 attributes per branch. Finally, we connect that into our construct attribute component, which already contains the name, the material, and the transform as the keys that we want to attach into our geometry. And that will give us as output, if we flatten here at the end, and that will give us as result 5 attributes which contain 3 values per attribute. Finally, we need to inject this into our geometry. So here we have in the attributes section, inject attributes component. We can now get rid of this component, which was the attached transformation component, because if we use this method, then we don't need this attached transformations component. We can put in our O input the geometry, which in this case is our 5 meshes, and in our A input our attributes. We can get rid of this grafting. So we have matching here 5 meshes and get 5 meshes, again 5 attributes. And finally, we can connect here in our glTF. Because we are doing this through this attribute system instead of through the materials input in our glTF display, then we don't need to input here the materials anymore either. We can preview off all the rest of the components, and then we get exactly the same result. The difference is that now we can add more information into our model. Before, we were able to first just add materials, second, to add materials and transformations, but now we can add material, transformations, and name. So if I save this model, and then we see it in our ThreeJS viewer, then we can see here internally that we will get the name that we provided. In this case, doors. And inside doors, we will have the two transformations that we sent. So here internally, we have the first door and the second door, which are just transformations. If we go even more internally, then we can see that each mesh is here contained in our scene tree. However, our names can also provide us even more hierarchy in our model. That's through adding points in our name. So that means that, for example, if I know that the first part is the body, then I can call these doors, point, body. Then the next one, for example, is the black section. So I can put doors, point black. Then the next one, we can see here, there is our glass. So we can put doors, point glass. Then we have the interior, so doors, point interior. And the second part is also about the interior, so I can put also doors dot interior. I can put this as multiple data. So we get it in this format. Let's see, we have 5 names. Yeah. And that means that now we need to also graft here, because now we also have 5 names and also 5 materials. And if we save this glTF and we check it again in our ThreeJS viewer, then let's see how our scene tree looks like. So we have here our main GLB. Then if we go internally, we have doors. And then if we go internally, we have body, black, glass. So now I can identify every single object that is inside my glTF. And that's exactly what we did with the entire Lambo. So if we start to check the other models, the other parts of the car, so if we go to body, we can see that in the body we have the name exterior.body. Then if we check the next part, for example, the wheels, then we can see that in the wheels we just add wheels, and we also have the transformations attached. So in this case, the transformations include scaling and include orienting. So we have 4 planes here, which give us our orientation, our transformation, but we are sending a single wheel. So we have this huge wheel here, which is a single one, but we are sending 4 transformations so that we can position our wheels in each section of our car, in each part, in each corner of our car. Then in the interior, we have several names. So for example, we have interior.seats, interior.engine, interior.base, metal, armrest, etc. That was what we saw at the beginning of the video. So you can really give a lot of hierarchy and identify every single geometry that you have in your model through the attribute system. And all of this through Grasshopper. Now, when you convert this into a glTF, so when I go here and I go right click, save glTF, that's like baking our geometry into Rhino. When we bake our geometry into Rhino, we are losing all the parametric structure. So our model becomes static. So even though here we have the capabilities of importing to ThreeJS, we are limited now to some specific attributes. For example, the visibility, where I can hide or show things. I could also change the materials of the geometry, like for example, Sketchfab easily allows us to do that. So if I go to the body, I could come here, change the material to another one. And here we are no longer in Grasshopper, outside of Grasshopper, but our glTF give us all of these attributes, material, name, and transformations that we can play with when we are in a glTF viewer. But of course, all what we show you about changing the wheel or changing the grill or changing the back plate, all of that was lost when we converted that into a static glTF. The way that you can have a dynamic glTF is through ShapeDiver. So this same Lambo, we can upload it to ShapeDiver. This is the raw ThreeJS viewer. And here we have it, of course, with a bit more of characteristics that you can use in our platform, ShapeDiver platform. And you have all of the same parameters that you saw in Grasshopper. Now we have them here. So we have still our glTF, but additionally, we haven't lost the power of parametric design, which our model contained. Here we have an example that was created by Sideberg, a web agency that collaborates with us. And here we can see that they created a complete user experience to work with this Lamborghini. So for example, here I can change the back plate. I can go to the body and then I can change the colors of the body. I can go to the wheels and access all the parametric options that our model has. They have some presets here. But we can also go to expert mode and get the other options that were also available in our model. Additionally, we can set up a very good rendering. So we can, for example, change the scenery. We can see that we have some lighting here. If we go dark mode, then you can see that we can control a lot of things from this Grasshopper model. Not just the geometry, not just the materials, object names, transformations, but also the lighting, the scenery, and finally, animations. And that's all for today. I hope you could see the potential of using the glTF format and that you could learn how to add metadata into your model. If you don't want to miss any other video about Grasshopper and ShapeDiver, don't forget to subscribe, to like this video, and if you want to see what other people are doing with ShapeDiver, then visit us at shapediver.com. And I will see you in the next one.